So it is my absolute pleasure to introduce Cory Watson, all the way from Nashville. He's Director of Technology at SignalFX. It's all yours, Cory.
Thanks. Mic worked as soon as I turned it on. Excellent. It is working great once I clip it on. All right, let's make sure the clicker works. It does. Hello, everybody. We've already stolen the thunder that I'm from Nashville. That was on the next slide, so that's okay. Today, we are here to talk about, got to figure out where the microphone is so I talk at it. Today, we're here to talk about humans. I did an informal survey before this conference started, and it turns out that most of you are humans. So my subject matter seems to be spot on, so that's great. If you're not a human, this talk is not necessarily for you. I apologize ahead of time. We'll get to that some other time. But today we're going to talk about something when I start my timer so that I can keep up with how fast I'm going in my talk. We're going to talk about something called the case method, which, full disclosure, is something I made up, but it is an acronym, and we're going to learn all about it. But what we're primarily going to learn about today is how to make monitoring better for humans. A big part of the systems that we run and operate every day is actually monitoring them and paying attention to them and making sure that they're working. How many of you are responsible for, you're supposed to, I think at the beginning of every talk, try to get everybody involved, so I'm going to do that too. How many of you run monitoring systems, make alerts, get alerted, get paged, on call, all these other types of things? Pretty much everybody. Good. This talk's for you then. So you're human and you're on call. That's good. That means that we're spot on. So first off, I was already introduced, but my name is Cory Watson. I'm from just down the road a piece in Nashville, Tennessee. I am a technical director in the office of the CTO at SignalFX. That means that I kind of do a little bit of everything. I'm sort of a customer in a can for our internal folks because I've got some prior experience that makes me helpful. We'll talk about that in a minute. But I'm also having conversations with folks like you, practitioners, all the time in kind of a pre-sales or post-sales situation, but I'm also doing R&D and all kinds of stuff inside the monitoring and observability space. Before that, I was a principal engineer at Stripe, where I created and led the observability team there for about 3.5 years. So owned a little bit of everything, including the tools that folks like all of you were using to do that monitoring and stuff like that, right? And then before that, I was an SRE and an engineering manager for the observability team. You're sensing maybe a pattern here. There's a lot of observability stuff going on in my career. I've been doing this and a whole bunch of other stuff for over 20 years in this space. Pretty much all of it, all the way back to when I was 16, 17 years old, has been on call in some capacity or other. I got my start at a dial-up ISP in, well, not Nashville, just outside of Nashville. Pretty much being technical support for folks, trying to set up Trumpet WinSock and install modems and stuff in their computers. That was exciting times in rural Tennessee. Anyway, despite the fact that I got my start helping people with modem initialization strings in Windows 3.1, I still love customers. And I still love the operators who deal with customers every day. And this stuff that we're working on is actually kind of hard. Not just because it's like sort of technically difficult, but also because it's changing a lot. And because dealing with problems, the things that come up when things are broken, which we've already been talking about quite a bit today, is just part of the job, right? Dealing with something falling apart or breaking in the middle of the night when it's very inconvenient. These are all things that we deal with as part of the job every day, but they're not super fun. We're also commonly focused on other stuff. We've even had mention today of paying attention to the fact that there is stuff happening in everyone's life, like you don't really know the struggle that everybody else is dealing with on a given day. We've also got pressures from, I'm sure none of you have had to deal with the pressure of having management tell you that you need to cut costs here or you need to add this feature no matter what because this big customer really needs it, et cetera, et cetera. Pretty normal part of the job, right? So simplicity is kind of where I start my talk today. Many of you have probably built something using the technical stacks that we set up today, and it was probably pretty simple. It was probably, just a simple application service, what have you, that you stood up. It probably had very few, if any, dependencies, and it was probably pretty well known. Like you could fit it in your noggin. Like you could sort of kind of wrap your head around it and you understood it. And you could lock that thing maybe in a closet and just shut the door, and if nobody messed with it, you would assume it would probably continue working for a while, maybe even forever. At Monitorama earlier this year, someone that was speaking, John Allspaw, asked at the beginning of the talk, How many of you, build and run systems, and a bunch of people raise their hands? You can do this in your head. We've already done the audience participation part. You don't have to do it again. But how many of you think that if you just shut your laptop right now and threw it in a lake, how many of the systems that you work on and operate every day would still be working in a week or 2 weeks or a month? That's the thing that we're mostly going to be talking about today, is how humans help systems continue to operate. So the problem with that simple system that you set up and you stuck in the closet is that complexity gets worse when you add a lot of simple things together. All of us are basically built from simple parts that, when you mush them all together, become very difficult and complex. And these quickly become a problem. Like, I'm not going to go through and do the thing where you talk about everything on the slide. You know about most of these problems. You know that even if you're on a local machine, you're probably actually talking over the network, even if it's just the loopback device. Did any of you use Terraform out here? Did you all know that Terraform actually communicates with the providers over RPC on the local machine? That's kind of weird, right? Didn't think about that problem. That's another problem that you could have if maybe localhost doesn't resolve right or something weird like that. That's pretty cool. So it turns out that complexity sort of happens to systems whether you really want it to or not. How many of you ever upgraded packages on your machine because you needed to update security stuff, and then there were adverse effects, like something else maybe broke? That happens all the time. Yeah, some people were so eager that there were hands that went up back here. I didn't even ask for that, and they just wanted to share. Like, that happens. So people and systems are often something that come up. You may recognize this Twitter account, which is one I run as a joke on the side, called Honest Update. And I've even fallen into the trap of associating things breaking with people. The point of this is that we have more uptime during the holidays, oddly, but that seems to correlate with people not being around. So it seems that when we're not around, this complexity seems to be fine, but if there are people introduced, then people sort of make things broken and worse. And it's not uncommon to be at a tech conference or be discussing these types of things and hear people malign other humans, because humans so often create problems in our systems. At least that's the way we tend to think about it. But the problem with people, other than them supposedly breaking stuff, is that they're kind of not going anywhere. There keep being more of them, and we kind of need them to make our systems work, right? Like, why are we building this stuff if people aren't using it? And humans are still pretty important in the function of the systems. Like, those of you who recognize that if you weren't doing the things that you were doing every day, your systems would fail, realize how important you are. I'm sure you feel that way about yourself, but hopefully you do about others as well. So humans are not necessarily bad. And don't get worried, but we are at a university, so we're going to look at some literature and some papers here in or at least one here in just a second. But it's a good one. So let's look at the literature and think a little bit about how people and systems interact. So this is a talk by a fellow named Dr. Richard Cook. It is a fantastic paper called How Complex Systems Fail. I highly encourage you, after this is over, to go take a look for yourself. It's not one of those big, 2-column papers with 20 or 30 pages and then 15 pages of citations after and stuff like that. It's actually very sort of thin and readable by people who just want to sort of casually browse in. But what Dr. Cook was talking about here is the large number of cases in the medical industry where we have actually paid attention to what people do in what has become complex systems, which is the medical industry. So we're going to talk today, again, about the case method, which we will talk about what it is in just a moment, but the point of that paper was to provide some backing for why I recommend that you do all of these things to make your monitoring better for humans, which is not just for you, by the way. We're going to try to make monitoring better for everyone while we're here. But the case method is a rubric for how you should handle alerting and monitoring at your organization. The point today, I think there's a goal slide, so I shouldn't tell you what the goals are. So the point of CASE is that it's an acronym to try to help you remember how to make good alerts and make them good for people. So the C stands for, and we're going to go back through all of this, you don't have to memorize it right now, but the C stands for context heavy, the A stands for actionable, the S for symptom-based. I feel like I should have come up with a song, little ditty. E stands for evaluated regularly. Some of you may be familiar with the RED method, made by Tom Wilkie, which is requests, errors, and durations, the sort of golden signals that you'll find in the Google SRE book. And others may have heard of the USE method, which is Brendan Gregg's utilization, saturation, and errors. So these are mnemonics just to sort of help you understand how to approach certain problems in complex systems, and the case method is the same. Now we're going to go through what all these mean, and I'm going to give you things from Dr. Cook's paper to help you understand why I've chosen these things to be important, other than the fact that it made a cool acronym. I tried a couple and eventually landed on this one. So the goal is to give you tips to try things that you can do at the person level, so yourself, just if you're working with alerts by yourself, or your whole team, or even your entire organization. This scales up to whichever one you're interested in the most. And the point is to consider the human factors of what it is that we're doing every day and how we notify people and how we get them involved in problems. Specifically, we're trying to help the fact that humans are intimately involved with the safety of our systems. We also need to acknowledge the fact that failure is going to happen in any complex system. We'll touch on that more in a minute. And we want to assist you in having a good learning culture and actually learning from your incidents instead of just doing the sort of go through the blameless postmortem dance. So the meta point that I want to make before we even talk about what case means and why there are these letters is that complex systems are intrinsically unsafe. Anytime you see one of these blue slides, that means it's something that's almost directly lifted from Dr. Cook's paper. So complex systems are intrinsically unsafe. All human actions are gambles. I'm sure we've all heard the pessimistic saying that just getting up in the morning is dangerous, right? Every time we operate a car or we do basically anything, we're sort of entering ourselves into some sort of cosmic lottery. Humans, interestingly though, are also doing this every single day and things are mostly fine. How many of you have ever typed RM minus RF or whatever the equivalent is on the system that you've worked on and gone, man, that could have gone bad? It happens all the time. You are implicitly doing things all day that have the potential to be extremely unsafe, but managing to pull it off, right? And that's because humans are both producers of safety and producers of failure. We're just more often producing safety than we are failure. And this is a modern take on how people interact. It used to be that we thought, hey, we need to automate all this, we need to get rid of it. But that's no longer the case. The other thing to keep in mind here is that expertise is changing constantly. You're getting better. You're hiring new people who maybe don't know these systems, or maybe people who have been around for a long time are leaving, right? So expertise is not constant. But ultimately, the goal today, the thing, if you take nothing else from this slide, I say that a lot, and it's for like 10 things in a slide, but if you take nothing else from this talk, please keep in mind that people create safety. So let's move into what the different aspects of case mean and why we're talking about them. So the first, the C, is context heavy. Humans are really adaptable creatures. We're pretty cool about that kind of stuff. Any of you who have ever operated a computer and it's asked you a question and you've tried to type an answer know that computers are less adaptable than you are. I was teaching my daughter some Python the other day, and I did something, I forget what it was, and she typed something that was basically correct, and then the computer errored out, and she said, why did it do that? And I said, because computers aren't adaptable. Haha, you should come to my talk. She didn't think it was funny. C stands for context heavy. And the reason that context is so important is that alerts are typically the first indication that you have that something is wrong. You're off eating lunch, doing something completely unrelated to work, and suddenly you're notified that there's a problem. So that's our first indication. These things need to be designed for the receiver. Most of us, when we make an alert, we make it for like future us. We make it like, I need to be reminded that the WAS job has been frazzled or whatever it is that you need to notify about. But you don't think about who else might be receiving this alert. And you need to keep in mind that who receives these alerts often changes over time. The person that receives it today is not necessarily the person that receives it 6 months to a year from now because systems change. So you should also be including intent. Like, what's the point of this alert? Why did you make it? By the way, you may start to read some of these and think, man, this is a lot of work to put into paging somebody. But that's kind of the point. If you're interrupting a human and taking valuable time away from their day-to-day and interrupting what they were doing, then you should probably put a little thought into how you do so. And then lastly, what goals did this alert have? What's the point of having it? So some other things that you can do for context here are, what's recently changed in this alert? Did someone recently tune it? Has it been modified? Did we change a threshold or something like that? How about who owns the alert, or when it fired last? Like, does this alert fire every Tuesday at 3 o'clock? Does it never fire? Because that's really interesting, right? If you get paged for something that you've never, ever been paged for, that's exciting, for some value of exciting. And you could also be helping people with the mental model. Especially modern tracing systems have the capability to draw full diagrams maybe of what's going on in the system. Some things are red, some things are green. That mental model is a very important part of what we use to ascertain what's going on in these complex systems. And lastly, how about any other activity that's going on in your organization, right? Did a big feature go out today, right? Is there a conference going on? Like, could you imagine working at a place like an Apple that's got a big conference that they hold, and then you don't know that there's some big conference going on? That seems like really valuable context. So this is a place where your tools can maybe help. Many of you are using some sort of alerting tool to get this done. Fun story that when I began working at Twitter, we didn't use PagerDuty or something. We actually used a medical on-call service that was used to paging doctors with very human things. And instead, they would page us with the output of our automated alerting systems and try to read it to us. So your tools are hopefully more, it was very adaptable, I'll give it that. But your tools may have way more features that you could make use of. So you should take a look at the tools that you're using for paging and see what information could they be providing that maybe you're not including in the alert today. Or whether or not your tools could be more social. Are these things that you're able to share with other people so that you know that people are being paged? Or are there silos where the work is maybe not shareable between teams? These are things you can do to improve context. We're going to come back to this at the end. So actionability. Humans are really, really good. This is the A, actionability. Humans are really good at resolving ambiguity. That joke I told earlier about my daughter in programming is one where computers are really bad at this. They don't know how to resolve this ambiguous nature of what they're supposed to do. Humans can. But we need to give them some information. So when you are paged, the most important thing I think about that page is that it's something that you need to take action for. This is not just letting you know that you happen to be out of file handles on a given process. It's important to know that there's some sort of action that needs to be taken. And these are things that you can commonly use, send people to a runbook. Or maybe there's some mitigation tactic that you can use, right? Or maybe we reroute traffic, fail over to a new place, make some DNS changes, whatever. But you also need a clear understanding of what was violated, and it shouldn't just be informational, right? Like, was this some sort of agreement that we have with a customer? Was it some sort of SLO that we've got set for our systems? We also need to make sure that the people on the other end are aware of any return time objectives. This may be a new acronym for some of you, but an RTO is this idea that, hey, this system is incredibly important and needs to be up within minutes. That changes your actions because you may take more drastic action for a system that needs to be up soon as opposed to, say, a reporting situation where, oh, that's fine, we can just bring that up by tomorrow, right? Lastly, we may need to help people with how to invoke the incident machinery in your organization. If you're lucky enough to have like an incident management program or something like that, then you may need instructions for how to pull that off. I'm gonna go a little fast here because I'm moving a little slow, but the big thing here is that whenever you get paged and you look at it in some sort of after action, post-mortem, whatever you call it, review, it's very common to go, if we had just known that we were out of file handles right there, we could have really solved this problem quickly. Be aware of this. This is called hindsight bias. This is something that you look back and go, if we'd known in that one occasion that this was the thing that was making it wrong, we could have solved it quickly. That's true. But the next time around, that's probably not going to be the reason. You don't want to fall into the trap of hindsight bias. This often means that you're going to have 1,000 little alerts, the rusting hulks of past incidents that sit around and page you incessantly whenever that thing happens that you've now coded around and you don't have to worry about. We're going to talk more about that in a moment, too. These all blur together when you practice the talk 100 times. How to diagnose and debug is another piece of important information that you can give to people at this phase. It's a good way to help people not be in the trap of expecting to be told exactly what the problem is. Action is not the same as fixing, by the way. Action is making it better, not necessarily taking it and making it go away altogether. So the S in case stands for symptom-based. Complex systems contain a changing mixture of failures. I started talking about this just a second ago. It turns out that the things that make our systems break or make them brittle today are not the things necessarily that happen tomorrow. It's very common to hear people say, like, well, you know, we knew about that problem last week. Why did it happen here? So everything that we work with today, I made the comment about Terraform earlier, everything is basically a distributed system, even stuff that runs on your local machine. These systems operate with lots of little failures happening. When you've got one or two machines that you're working with, you don't see a lot of hard drive or memory parity failures, but when you start to run with thousands or tens of thousands of machines, suddenly there are disks and memory failing all over the place. And our systems work exactly the same way. Any of you who are starting to get my age and you get up and realize your system is kind of always in a slightly failing mode, like you got that one trick knee or your elbow doesn't work right, like these are things that just happen all the time. We cannot possibly enumerate all of the ways that complex systems are going to fail because they fail in interesting and exciting ways all the time. You will never ever make an alert for every possible failure. So instead, we need to focus on what's important. So symptoms are a way better thing to monitor than causes. The reason that whenever you go to the doctor's office, they say, hey, let's take your blood pressure, let's take your temperature, let's check your weight, let's check your height. These are your vital signs. These are the things that if they change, there's probably something going on under the hood, and maybe we need to talk about that. But when you go to the doctor's office, they don't immediately present you with a panel for every possible test that could ever be done. Not only is that ridiculously expensive, but it's unnecessarily complex. Because if we just pay attention to the symptoms, then we're more likely to be able to find the underlying causes. Doctors will then diagnose you after the fact, which is very similar to what you do when you find out that your systems are busted. So this is a place where you can really benefit from an investment in observability. That's not what I'm here to talk about today, although I often do. But the point of observability is to be able to find why the system is behaving the way that it is by looking at its outputs. Sorry, looking at the time. Doing good. So when we see that the symptoms are busted, you may say, well, how do I know what's wrong? All I know is that, say, the equivalent of the temperature of the system is out of whack. Well, that's the thing we have to work with all the time. Practice is what helps us with that sort of stuff. You can tell I'm giving this talk a bunch in practice because I keep alluding to the next slide before I get there. So one more thing I want to say here is you may be thinking, Cory's on stage telling you right now that you should never, ever alert on causes. That is not true. As someone who has for a long time operated these systems, I realize that you will often need to alert on causes. It's very important. But these often are things that you should think of as temporarily unsafe situations. If you know that you have a memory leak or a file handle problem or this one weird situation that happens from time to time that we haven't identified, that's an important thing to alert on, but these need to be time-boxed. You don't want to leave them lying around forever. And the action that you'll take here, you may think, well, what's the action for this? I don't know how to fix it. It's a weird new bug. Well, the action is that you need to show people how to get more information. Like, for example, if you know that the system is leaking file handles, but you can't figure out why, when you see the file handle alert, please run LSOF on this PID, tell me what files are open, that sort of thing. That's the action that you can take and ultimately remove these alerts whenever you hopefully fix that bug. If you get paged for a lot of causes, or if you're having a lot of places where you have to set up cause-based alerting, the short version of this slide is basically you're probably doing something wrong and you need to go back and either work on the quality, the testing, or the processes that you allow things to get into production with, because they shouldn't be going into production with a lot of these problems. They're going to happen, we have to accept that, but they shouldn't be the sort of thing that we deal with on a day-to-day basis. So the last part of case is that your alerts should be evaluated regularly. So I really like this slide because it's sort of an oxymoron. Failure-free operations, not having failure in your systems, requires that you have experience with your systems failing. It's an oxymoron, welcome to adulthood. This stuff is just hard. So if you want to be good at dealing with failure, you have to fail often. This is something that was alluded to earlier in a talk. Like basically failure yields success. So if we're going to make our systems better, we have to experience failure with them. So you may think when I say evaluated regularly that I'm sort of like saying, should this alert exist? I am, but it's way more complicated than that. My question for you with a given alert that you've got set up in the system is, does it actually do what it was designed to do? Do you know that that alert that you set up to monitor unsafe conditions in your system actually fires when the conditions are unsafe? The only way for you to know this is to experience the conditions becoming unsafe and then you being notified about it. So this requires actually putting the system into a weird place. There's a bunch of ways you can do that. You could use a game day, which is this idea that you set up the thing and get it all prepared and everybody's at attention and by their phones and they run the process and they say, look, we did that cluster failover today and it did exactly what we expect. There's also fault injection where you intentionally sort of add error to the system on purpose to try to exercise it and make sure that it does what you expect. You can very easily do this even with metric systems. You can inject fake exceptions into the system just to see if the machinery works the way that you expect. And lastly, chaos testing. Intentionally pulling the plug on a server is an excellent way to know if monitoring the server is working. And you may think these are a little bit scary and a little bit of work to set up, but they're the only way to know that the things that you've set up to monitor your systems are actually doing what you expected. Also, if you go out and you look for advice on how to set up good alerts, the most common bit of advice you're going to see is to remove alerts. It's okay advice, I suppose, although a little sort of cheap. The better solution here is to think about what these alerts do and how they inform you of what's going on. How many of you have both a deadbolt and a normal lock on your front door? You don't actually have to, okay, great. I was gonna say, I feel like I'm bad. I keep making you all raise your hands. So think about how many times you've tried to lock the bottom lock, the one that isn't a deadbolt. And you've like turned the key and then you went, okay, it's locked. And then you took the key out and then you turned the knob and you're like, and you had to go back and you had to do it again, right? How many times have you had to do that with a deadbolt? Almost never, because when you get it, it goes ka-tunk. And you get that really satisfying bit of feedback from the door that the lock is set. The same thing goes with alerts. Some alerts are actually very reassuring. They may not need to page people, but it's very reassuring when you do a cluster failover to get a notification that's like, hey, the cluster's failing over. That sort of affirmation is very helpful. You often find this in discussions, not just in the medical industry, but also in the aeronautical industry, where the cabins of an airplane make a lot of weird noises whenever people are doing things, and that's okay. They know when they're landing that certain things are going to happen. This is not uncommon. This bit of feedback actually helps people. So don't just remove alerts. Just think about how people are seeing them. Maybe you can just send them all to a Slack channel. Don't send them all to email, because we all know nobody reads those. So some ways that you can set up evaluation of your alerts, aside from just saying, like, we got to make it fail to determine if it's working. Put expiration dates on them. Put it in a comment inside the body of the alert that says this was last looked at. You see this often on the back of bathroom doors, where someone has just said, hey, I took a look at this recently. That's really helpful, because you know where to go if you see something weird, and you can say, hey, you were in here. Why didn't you notice that there was this weird thing going on? Facilitation of ownership, making sure that people feel comfortable with the idea of modifying and manipulating alerts, right? Because if they don't feel comfortable changing them, they're not going to make their own situation better. This is something that often is easily done with something like Terraform, because you can send pull requests, which is very helpful, right? You don't have to worry about who set this alert up and is it okay to mess with this threshold and stuff like that. Allowing feedback is one that very rarely seems to come up. But you could just put a Google survey in the bottom of every alert that goes out to people. And it also doesn't have to be super fancy like a survey. You could just put, if it supports something like Markdown, you could put 2 links. One that's like, this alert was helpful, which like alerts you to some sort of yay GIF. And then one link that takes you to, this was unhelpful, and it's like a big boo GIF. And then you use access logs on the system that handled the request to help you count up how many people are selecting this versus that. But some method of evaluation for whether or not the alert was helpful. So we've made it through all the acronym now. Why do we need something like this? We make a lot of alerts, and they bug a lot of people, and the idea of directed attention and this sort of stuff that comes from psychology is very important in us operating these systems safely. Failure is inevitable. You're going to have to deal with it. The humans, though, they both create safety and foment failure. But remember that we're creating a lot more safety than we are failure. The review of problems after the fact often has a heavy bias, so that's something we need to be careful with. And also preparation, dealing with failure and being used to it and expecting it to happen is key for us to make sure that we actually are doing a good job with this moving forward. So let's review what case is one more time. Improving monitoring for humans is the goal here. If we were just sending these to some Skynet thing that resolved them for us, that'd be fine, right? But we're not. We're sending them to humans, and so we need to think about that. We need to give them a lot of context, make sure it's heavy on information where possible. We need to make sure that the thing that they've been asked to look at is actionable. How many of you have gotten alerts and just you look at the phone and then you just put it right back in your pocket because you're like, that's not even that big a deal. I love I ask and a lot of hands go up. We also need to be symptom-based. We need to be alerting on things that actually affect the system, that matter to customers, instead of just alerting on weird things like the amount of garbage collection or that there are too many clients. Unless these are actionable, why am I being told? And then lastly, we need to evaluate them regularly, both intentionally, like with something that causes them to go off, and artificially by just inspecting them with a human to make sure that they are doing the thing that we intended them to do. So how can you case? What can you do to make sure that your alerts are good and that you're following this rubric? The first is that for the context, look at the tools you've got today and say, like, well, what could I add here? Many of these systems are sort of template-based, so could I decorate the subject? Could I put more things in the body? Are there things I could add to the metrics, the logs, the traces, whatever they are, that ultimately decorate that with more context and help the human understand what to do? If it's actionable, how so? How can I help the user know what to do next? And remember that action is not just fixing the problem, it's also making changes that make things less impactful, reducing the impact radius as we described earlier. We need to make sure these are based on symptoms, not on problems, that this isn't going to age out, and like next week we've just got a bunch of alerts that alert us on something that's not really important anymore. And we need to evaluate it regularly, which we can do by just sort of putting a timer in it. Like worst case, you can put a date that says like, Cory last evaluated this on this date. And then maybe add something that looks through all your alerts and picks up the ones that haven't been reviewed recently and then flags them so that people can take a look. So I'm not sure why I have another slide about making things better for humans, but I do, so we're going to talk a little more about it and say that we need to think of the recipient and give them assistance. Really, that's what we're doing here. We often think of ourselves being alerted, but we're actually alerting our friends, teammates, coworkers, even our future self who at 3 o'clock in the morning is not nearly as sharp. We need to ensure that the next steps are known, that we know what we're going to do with this thing. We need to alert on symptoms, not on causes. I'm going to keep saying that one because it's important. We also need to sort of use and tune and mess with these things all the time because that keeps them healthy. It's sort of like gardening, right? And then lastly, we need to remember that this is something that you can do as an individual. You can tune and mess with any alert you've made, or your entire team can work with this, or your leadership could even say something like, hey, we should all be paying attention to this because alerting people is annoying and frustrating if it's not done correctly. So thank all of you for coming and listening to this talk today. I did pretty good, 29. Yeah, you don't have to hold up the minute sign. So if you'd like to engage with my brand, you can do so on Twitter. I do things at @GFAT there. My website is onemogen.com, where I have written a few things about Case, which if you'd like to find out more, you can find there. I'm also on LinkedIn if you want to do whatever it is people do on LinkedIn, besides recruit each other. So Case over here, again, context-heavy, actionable, symptom-based, evaluated regularly. And also, these papers at the bottom, don't take my word for it. Please check out some of these papers. Well, the bottom two aren't papers, they're just blog posts, but the top one on why complex systems fail is well worth your time today, and will only take a few minutes to read. It's very approachable, unlike a lot of papers written by the medical industry. So thank you so much, and thanks to the organizers for putting all this together, and have a great rest of the conference.